Merry Christmas. The paper of the day is Centaur, a framework for hybrid CPU FPGA databases. Accelerating relational databases in general and SQL in particular has become an important topic given the challenges arising from large data collections and increasingly complex workloads. Most exciting work, however, has been focused on either accelerating a single operator, example a join, or in data reduction along the data path from disks to CPU. In this paper, they focus instead on the system aspects of accelerating a relational engine in hybrid CPU FPGA architectures. In particular, they present Contour, a framework running on the FPGA that allows the dynamic allocation of FPGA operators to query plans, pipelining these operators among themselves when needed, and the hybrid execution of operator pipelines running on the CPU and the FPGA. Contour is fully compatible with relational engines as they demonstrate through its seamless integration with MongoDB, a popular column store database. In this paper, they describe how this integration is achieved and empirically demonstrate the advantages of such an approach. The main contribution of the paper is to provide a realistic solution of accelerating SQL that is compatible with existing database architectures, thereby opening up the possibilities for further exploration of FPGA-based data processing. Paper uses Intel's Xeon plus FPGA platform with MongoDB to deploy Contour. They modify MongoDB version 11.21.19 to integrate the application interface of Contour and allow hardware UDFs to execute on the FPGA. The FPGA architecture of Contour is configured with 4 operator units and clocked at a frequency of 200 MHz. To evaluate the overhead of the F threads manager on the QPI throughout consumed by the F threads, they compared a copy operator, example read a cache line and write it back, to the Intel AAL loopback benchmark provided by Intel. Now let's look at the contributions. There are 4 key contributions of this paper. A high-level software abstraction for hardware operators called F-threads, hardware architectures that facilitates concurrent and dynamic offload of database operators to the FPGA, dynamic pipeline of operators to overlap processing of either hardware and software or multiple hardware operators, exploring and demonstrating the functional integration of FPGA accelerators into database engines through UDFs. Now let's talk PS score for this paper. Overall, this paper is a decent read, so it gets 6 out of 10 on readability. With 8 pages long, it scores 6 out of 10 on length. It's a research prototype with okay-ish descriptions, so that makes it 7 out of 10. Its industry value and learning meter is decent, so it gets 10 out of 10 on each, with overall PS score of 7 out of 10.